Good evening, Yethedeens. It's getting rather late and my voice is starting to run out, so this might be my last video for a little while. But we're looking at gradients at a point, and this first example here really ought to be revision of what you've done in year 12, but I'm going to go over it anyway. So it's asking us to calculate the gradient of the curve at this point here. So in order to calculate a gradient, we always have to differentiate. So let's start by differentiating this function, and we'll get 3x squared minus 3x. And if we want to find the gradient at a point, we have to substitute this value for x in. So I'm going to write m for gradient, and I'm going to write 2 in brackets to show that I'm substituting in 2, and that's going to be 3 times 2 squared minus 3 times 2. So that's going to be 12 minus 6, which is 6. So the gradient at that point is 6. That's our answer. Okay, so let's look at a slightly more complex question. So this one here is asking us for the tangent. So for the tangent, we need a gradient and a point. Okay, so we'll start with the gradient by differentiating. So dy by dx will be 2x minus 5, and we'll substitute in the x value of 3 to get the gradient. So that's going to be 1. Okay, once we've got the gradient, we've also got the point. We can use the gradient intercept equation. Y minus y1 equals mx minus x1. And this should all be familiar to you from your coordinate geometry last year. So we're going to have y minus negative 2 equals m, so that's 1 from over here. So that's where that's come from. And then x minus x1, which is 3. So that's come from here. So now it's just a matter of simplifying. So we've got y plus 2 equals x minus 3. And you'll probably find in the answers they make one of the sides equal to 0. So they put everything onto one side. So I'm going to subtract y and 2 from both sides. And that will give us x minus y minus 5 equals 0, and that's our equation. If you want to have it y equals, that's fine. It really doesn't matter what form you have, so long as it's equivalent to the correct answer. Okay, well, we seem to be ripping through this pretty quickly, so I'll go on and do this last example. So it's asking us to write the equation of the normal, and so all we need to remember for normals is that when you multiply a normal gradient with the gradient of the curve it is normal to, the gradient's multiplied to negative 1. So let's start by finding the derivative of y. So dy by dx is going to be 3 minus 6x squared, and so we're going to put negative 2 into this function to find the gradient. So m at negative 2 is going to be 3 minus 6 times negative 2 squared. So that's going to be 3 minus 24, so it's going to be negative 21. So one of our gradients is negative 21, so that means negative 21 times the gradient of the normal is going to be negative 1, and so the gradient of the normal is going to be 1 over 21. Now we have a point and a gradient, so we can write out our gradient point equation. Y minus y1 equals mx minus x1. We can substitute in the things that we know. So y1 is 10, and m is 1 over 21, and then we've got x minus negative 2. So expanding our brackets, we've got y minus 10 equals x over 21. That's going to be plus 2, so plus 2 over 21. Now usually when we're writing our equations we don't like to have fractions, so I'm going to times through by 21, and that will give us 21y minus 210 equals x plus 2, and we'll get everything onto one side again, and so that will give us x minus 21y plus 212 equals 0, and that's our final answer. Okay, so have a look at exercise 16.08, and yeah, just really glorified revision from year 12.